Welcome, software engineers, to day 9, the end of week 5 in CSC 222 software engineering. Thank you for being with me today. I appreciate your attention, your rapt attention. I do appreciate that, because no matter what I do, to my best efforts of dealing with technology, Blackboard is so recalcitrant. And I think it shows all this. I don't know why it doesn't show when CNCS4 is due. All right. So I think that, and this is probably a good idea anyway. I should just do this so you know. Oh, this looks horrible. Last time we mentioned assignment 9, and that got released early, and some of us panicked. That was to read that article by Fred Brooks, No Mythical Man Month. And for this first thing, all you need to do is state Brooks' law. You'll read about it, but just state it in your own words. You might find, how do I, just put it in your own words and just a tiny bit of explanation for it. And that's all that's required in assignment 9. I didn't want it due just the next time. That's pretty quick, but it is due Friday on Blackboard. Assignment 9, Fred Brooks. You'll find that article there also posted on Blackboard under the Unit 1 link. Assignment 11 that we saw before, and I'll see if you have questions about it, about the middle of class today, is the next sprint in our Add Numbers program. At this point in time, I've been waiting a little bit to make sure everybody's caught up. If you're not caught up, get caught up, because we're going to do this one and there'll be 2 other ones. And then soon we're going to be working in a team with a concurrent project also. So I don't want you to get behind in the programming aspect of what's happening in here. Software engineering includes programming. What I said the first week is it's not just programming. This is not just coding. It is programming plus. So yeah, coding, we've got to do as software engineers. Programming, we have to do as software engineers. There's more to it than that, but we got to do it. So do it. Assignment 11 is sprint 3. Is that right? Or 2 or something? We'll look at it. And we'll take a look at the requirements and specifications so you know exactly what is required. And one thing you've noted is, there's a big difference between knowing and understanding the requirements and specifications and then doing the design and the implementation. You're right. Absolutely. Exam 1 will happen the next time we meet on Monday. During the course of CSC 222, there'll be 3 unit exams, 1 at the end of each unit. There is no cumulative final exam in the course. There are 3 unit exams. The cumulative thing are the projects, the programming projects. So exam number 1 will happen online at Blackboard. Sorry, I won't go there and hand out paper. Similar to the quizzes that you've done. The difference is the exam will contain true, false, multiple choice, and a few short answer questions. I think I alerted you to the possible short answer questions last time. Think in big, broad brushstrokes. What are the grand ideas? What are the big topics and concepts that we've discussed in class and you've read about in the book? Some of those have been on the quizzes. Sometimes the quizzes are in a little more depth because they just cover a week than this exam will be. I will be with you on Monday. I'll probably say a couple things up front, and then you'll have the time to do the exam. The exam is timed, so you can't have an unlimited amount of time to do the exam. I will ensure that there's what I believe is plenty of time to do it. The exam is open book and open notes in spite of anything else that might be said on Blackboard, but closed neighbor, closed online resources. So we're on the honor system here. We're all adults. You can reference any of the material for this class on Blackboard, or any other kinds of notes that you have taken. That's legit to use. Please don't browse them on. It's not going to help you. Wikipedia is wrong when it comes to this anyway. So it's not really going to help to use any online resources, and you really don't have time. One of the downside of an open book, open note exam is sometimes you feel, well, okay, I know the answer, but I think I'll just check it. Suddenly, you spend 30 minutes on one. Don't do that. Don't do that. Just use it as a final resort. Something you said, oh, I got to look that up, and that'll be fine. Because the next time we meet, and because also we're a little bit offset when the weeks come, because we had Labor Day Monday off, no quiz this week. We may or may not resume those in Unit 2. We'll see. So far, very few of you have bribed me. If more of you will, okay, kidding, we'll see what happens. And finally, the CNCS assignment that we'll begin discussing today is due next Wednesday. Typically want you to have a week to do the Christianity and computer science assignments. So here's where we're going. Let's talk about assignment 9. We've already talked about. I'll review something in a little bit about Brooks. Assignment 11, we'll talk about it in a little bit. Any questions, comments, or concerns that strike you immediately about exam number 1 next time? Did that get on Blackboard? I bet it didn't. I've said there's going to be a list of review type questions there. I bet that's not there. I got so excited because I was finally able to kick Blackboard in the head and say, 2020, 2024, can we get everything to be 2022? And I think it did that. And then I let up. All right, I'll double check that. You're saying, why don't you just tell Siri to remind you? Well, first of all, it never does. And secondly, there's something about the process of actually writing it down that really clicks it in most people's brains, right? So see, I'm writing down. Put the review doc online. Any questions that come up? Make-believe cash doesn't cut it. Bitcoin? Okay, that'll work. All right. Think about it. If anything comes up, let me know. It'd be okay to talk about it even later, even though we're moving on. That's a-okay. Don't panic. Yeah, right. Sometimes if you haven't had the instructor before, you're worried, what kinds of questions will he ask? I got a little sense of that, I think, in the quizzes. But last time I shared with you 3 potential short answer questions. You remember those? Yeah, the odds of those being the questions are really, really high. If you miss those, review the course cast or ask a friend. Onward. You haven't heard this before. Software engineering can be defined as the management of the entire software development process. Don't forget, when I ask you this question next Monday, you will write this, but don't stop there. This is 1 out of 5 points. You've got to write some more. Thank you. Wally. I've decided to become more of a big picture guy. Lesser minds can do the managing and implementing. Well, I criticize them for not getting it. Dilbert. So you want to get paid to be a jerk? Said the implementer. Let's review that concept. Not the jerk part, but it relates to software engineering, and we'll do that in a little bit. Another way to think about software engineering, not the definition, but a great description, an abstract description, is professional problem solving. And I thank you for allowing me to share with you some aspects of professionalism. So I want to share, this is week 5. It's an N-1 thing. So let me share with you my 4th aspect of professionalism, being a team player. In the next unit, we're going to divide ourselves into teams. Well, I'm sorry, I'm going to put you into teams, and we're going to be doing a team development project. It's scary. Sometimes we don't like working in teams, and we discussed before the advantages and disadvantages of a team, and those are all true. But the reality of the situation is, in the 3rd decade of the 21st century, I'm not aware of any software that is developed by individuals. I mean, I go to companies, I ask all the graduates that I know from MEC1, when you graduate, would you please send me a message if you ever are, if the boss tells you, go sit in the corner, implement this thing yourself, yeah, that's very unusual. Being a team player, as difficult as that is really the mark or characteristic of a professional. I think you see a pattern developing too. I'm going to relate my aspects of professionalism to one of the commandments. Now, at first blush, this also doesn't seem like a team. The 4th commandment, honor your father and mother. Now, when you go and read Luther's explanation to the 4th commandment, you will discover that what God has in mind here is more than just the vocation of family. It also applies, as Luther says, not only to parents, but other authorities. And we always have authorities, right? Darn. You wonder, when do I get to be the boss? Well, I know you think I'm the boss, but you know what? I have to report to people also. I mean, I share what I'm doing with Professor Tallman, and he says, what's wrong with you? Can't you do it the right way? Yeah, so got to change. Oh, thank you for not telling him I can't figure out Blackboard at all. Here at my home university, Concordia in Mequon, Wisconsin, I mean, there are deans, there's a provost, there's a president. Yeah, there's always authorities around us. So what does it mean to honor them? Well, believe it or not, being a team player. Okay, here's trivia, baseball fans. Props, but no extra credit if you can identify this mid-20th century baseball player. Got a little hint there. He's got a Giants uniform, but guess what? It's not the San Francisco Giants. It's the New York Giants. See that program there? 1954 World Series. Anybody know who that is? And you hope nobody there calls themselves a baseball fan. This is the greatest. This is the GOAT, right? The greatest of all time. This is Willie Mays. Now, before you put in chat that you think you got somebody else who's the greatest of all time. Oh, nice one. Yeah, just very good. Willie Mays. Willie Mays was a consummate team player. His teammates said he was always encouraging to us, not in a sappy way. Oh, that's okay. If they screwed up, he'd let them know, but he didn't yell at them. He took them aside and he said, can we just, okay. Willie Mays had his own special way, but basically, could we discuss what went wrong here? Let's work on that. Let's talk about this. What did you see and think? Let me show you a better way to do it. Willie Mays was a 2-time MVP. I don't believe he was ever paid $1 million. He was in the era before that, although worth much more than that. A 19 or 20-time All-Star, played his entire career with either the New York Giants, the San Francisco Giants, and then the last year, San Francisco Giants traded him back to New York, and he was a Met for 1 year. Okay, I'm ignoring that part of his career, but a consummate team player. There's one story about Willie Mays that people say, well, he wasn't very good too. This is in the era when, in the middle of his career, when he was really famous, he was a really great player. Everybody wanted to interview him. And Willie Mays said, fine, you want to interview me? $50. And people said, what kind of hot dog guy is that? Well, they still paid him. You know what he did with that $50? He paid the last 2 players on the roster, player 24 and 25, gave them an additional $25. And really, in the 1960s, they might have been making $25 a game. Wow. So, okay, you want to impress me? Tell me some Willie Mays stats. That's pretty good. I really wanted to do this, and I don't know. I've got the rip of this on my machines at work, and I know I did it at home because I have a legally licensed copy of the DVD, but I can't find it. You saw that I sort of enjoyed Chuck Norris. Chuck Norris has been in many movies. I don't think we call any of them an A movie. They're all B movies. This is top dog. And there's a great scene in this where not only is just Chuck Norris, roundhouse kick everybody in sight, but he single-handedly stops a speeding automobile. Well, at the very end, the robbers have a Bozo the Clown mask, and he kicks one over and he says, "Let's go, Bozo." The moral of the story is, when we do teams, or you're working in a team, don't be the bozo on the team. It's related to a common IT phrase. It's called "don't flip the bozo bit." Read about it in the text. And not that I'd ask you, but it's just a common IT phrase. Sorry, can't watch it. Yeah, one clip's on YouTube, but I kind of refuse all those ones, all those folks who monetize and they want 29 ads in front of them. And they're all political ads now. It's already old. Can I share with you what some other people think about being a team player? 10 qualities an effective team player: demonstrates reliability, communicates constructively, listens actively. I wonder, human resources articles. Okay. I'd have to page down too far to actually get into this, so I won't page into it. But you can think about what would be a good team player. And one way you could do that is to say, what attributes do I want in that other person on my team? Well, I could tell you. You want that other person to be present with the team. If the team's going to meet, wherever it is you guys meet there at Irvine at 9:30, you want them to be there at 9:30. You want them to be engaged. You want them to be prepared. You want them to be civil in speech. You want them to contribute. You want them to pull their weight. Yeah, exactly. Just most companies are really concerned about hiring graduates who exhibit team player capabilities. It's hard to always welcome collaboration. Working with a team means there'll be varying opinions and ideas. Even if you think your idea is best, you should listen to all the ideas before pushing yours. Search for compromises, remain respectful if your work is criticized. Easy to write that stuff, very hard to live. that stuff. Yeah. So in CNCS4, you're going to think about team player, fourth commandment, make some connections there. You're all doing great on this. I appreciate that. I do need to give you feedback on CNCS3. Comes shortly. You recall that Monday was Talk Like a Pirate Day. I just can't let that one go. What do you call a robot pirate? R2D2. What do you... As soon as somebody laughs, we'll go on. Thank you. We're at the end of Unit 1. Let's review the major phases in the software development lifecycle. SDLC, software development lifecycle. What is that thing? That is the framework we do. That's the framework we use to do our job being software engineering. In other words, it's how you manage the entire development process. The one that I'm advocating and sharing with you has 6 major phases. We've spent a lot of time with these first 2. Requirements. Keyword, why? You know, on the exam, when I ask you, so what's the purpose of the requirements phase? What's produced and why is that produced? Well, you'll be able to say some things. The key word is why. Why is there a problem? Why is a computerized solution needed? And then beyond that requirements, we ask ourselves, what outputs are needed to solve the problem? What information would the user need? That's requirements. The next major phase in the software development lifecycle is specifications. And its key word is what? What does a good solution look like? What does this good solution do? The focus here is on not just the outputs. Requirements began looking at the outputs, but the outputs and the inputs. So when I ask you on the exam, what's the purpose of the specification phase, what's produced and why, you have some sense. You'll review that? Good. Now, there are 4 more phases. Although we've done this, and I know you've done it, we haven't fleshed it out. And it's not really for this unit, it's for the next unit. But the next major phase is design. The key word with design is how. How will this product solve the problem? When we're talking about how in computer science, we're talking about algorithms and data structures. Come on. You've done this. You've done this a lot. The very first week I mentioned you're familiar with programming in the small, AKA, also known as coding. Software engineering is programming in the large. Instantiation is the phase when we actually change our design into a programming language. We actually fire up Visual Studio. We actually throw C#. We do it. But you see how far into the software development lifecycle that is. Instantiation. Design and instantiation will be the focus of Unit 2 in this course. That brings us to the final 2 phases, deployment, which you have already done. And we're going to keep doing it until we all get it right. It's not straight. I have to find it and I have to rename the file and I have to, why am I doing that? Because you're going to discover that when you work in industry, they're going to have a very specific way of deploying software. There might be a lot of strange steps there also. And it's very likely you can't just turn to somebody and say, hey, do this. You might be the person doing it. The final phase is maintenance. We did say either in week 1 or week 2 that software engineers end up with 2 kinds of jobs: creating new systems, new software, maintaining current old software. And more software engineers are involved with maintenance than in new instantiation. The new stuff that's what's fun, cool, sexy. But the maintenance is where a lot of the money comes from. Yeah. All right. Now, another way to think about these phases of the software development lifecycle. These first 2 are known as the front end of software development. My wife and I shared this with you. My wife and I own a 1990 ZR1 Corvette. This is it. Okay. The front end of SDLC means those things that precede the implementation. The idea is what comes first. You'll hear people talk about a job as front-end developer. That's something different. A front-end developer is somebody who, in a client-server environment, like a web, creates the web front end as opposed to the server-side back end. So it's using JS, JavaScript, something or the other to do all the stuff on the front end of the web. And that's not what we're talking about. For us, front end means what we've done in this unit, the idea of software engineering. The next 4 phases, design, instantiation, deployment, and maintenance, then, are oftentimes referred to as the back end of software engineering. The back end. And yeah, that also, in some circumstances, like client server again, means what happens on the server side. But for us, when we're talking about the SDLC, back end are these phases after idea. I was going to tell you a sad story. Holy cow. Some of you guys are didn't Lotus co-design the engine in that car? Oh, thank you for trying to get me off track. I'll be happy to do that. The ZR1 Corvette in the 4th generation was very unique. As a matter of fact, it had the only design engine that was a dual overhead cam until 2023. The new Z06 Corvette has one also. And yeah, the engine in my car was designed by Lotus Engineering. In the 1980s and 90s and 2000s, General Motors owned a majority share in Lotus, the British Lotus Corporation. So this was a one-off engine, a very low production engine. And as a matter of fact, the engine was not made by GM. It was actually created by Mercury Marine in Stillwater, Oklahoma, because they were the experts. It's an all aluminum engine, etc. So yeah, thank you for saying that. And I need to share with you sad news. I had a track day scheduled for Friday, and I made the mistake. My car has many blemishes on it, but I wanted the hood redone. Every once in a while, I bump a cone or bump a wall or something like that. So I took it to a very reputable shop. I took it to them on August 26th, and they said, oh yeah, we'll be done in 5 days. And I told myself, no way, it'll be 2 weeks. Well, Friday, it's 4 weeks, and it's not ready. I bet you feel bad for me, don't you? I need to set software engineering in a higher conceptual stage. Levels of problem solving. When it comes to technology, we know that computers are tools for solving problems. We know that computer scientists, that's our job, solve problems. But solving problems happens in a couple different ways. Let's investigate 2. One way that you can solve problems is using algorithms. An end user, a regular old person like me, grabs that app and says, great, now I have an app that will add numbers. Now I can type in 0.21, 0.33, boom, 0.27, boom. And magically, the running total appears. This is a legitimate type of problem solving using algorithms. The other legitimate type of problem solving, and there's actually one more, which we won't get to in this class, is creating algorithms. That's what software engineers do. That's what programmers do. That's what computer scientists do. We create the algorithms. Now, caution. It's easy to look at this and say, creating algorithms, that's much more important. It's much harder. It's much more beneficial. These are just two different levels of problem solving. It's not like using is lower than creating. They're just different. Using algorithms, creating algorithms, why am I talking about this? Because when you create algorithms, you think in a specific way. You order things in a specific manner, exactly as we've done with the software development lifecycle. The catchphrase, the three-letter acronym for this is OIP, O-I-P. Well, what in the world does that stand for? OIP stands for output, input, processing. When you create algorithms, the first thing you need to consider are the outputs. The outputs, does that seem backwards to you? I hope not. The outputs are the information the user needs to solve the problem. That's what we got to determine first. Hey, guess what? That's exactly the point of the requirements phase. Figure out the outputs. Figure out the information. The point of the requirements phase is to figure out output. And notice that comes first. Then the I. The I is input. Oops, sorry. The I is input. Once I know, hey, this is what I got to give the user. I got to give the user a sum of all the weights of the shims. I've got to give the user the total number of shims in that package. Now, what data does the user need to give me in my algorithm such that I can compute those two things? That's input. And that's exactly what we're determining in specifications. Specifications wants to know what data will the user give me in order to produce this information. Requirements, specifications, outputs, inputs. And then you'll notice the third thing is the P, that's processing. Now it's time to do the algorithm. Now it's time to say, okay, the user's going to give me a floating point value. What do I do with it? How do I accept it? How do I compute a running total? What's this idea of event-driven? All that kind of stuff. This is how you need to think as a software engineer. Notice that it's different than the way users think when they are solving a problem. Users think of things this way. Users think IPO. All right? First thing I'm going to do, I'm going to give this app some data. And then I'm going to punch the button that says process or add or whatever. And then thirdly, the results are going to pop up there. Yes. Users think in these terms. And that's why when we've talked about the user experience and the user interface, I've said, look, put it this way, input at top, your processing button, and then output or left to right. This is the way users think. And it's different than the way we think. And when we're first trying to get everything together in computer science and software engineering, it's really easy to get these two confused or muddied. We are really switching gears all the time. We have to think about our user and the way the user considers or thinks about the problem. But we also have to consider how we're going to solve the problem. So focus on the software development life cycle, because it does this: output, input, process. Now, let me illustrate. You might think, thinking about outputs, isn't that like totally backwards? Because that's the last thing the user cares about. No, this is actually what they really do care about. If you're not familiar with Blaise Pascal, I look at Blaise Pascal as one of the, whoa, earthquake, as one of the two co-founders of computer science. You're thinking, when did he live? 17th century, 400 years ago. Wilhelm Schickard, Lutheran pastor and professor at the University of Tübingen, created the world's first mechanical calculator in 1623. Pascal did something different. He knew nothing about Schickard, did it in the 1640s. Pascal, in addition to creating one of the world's first mechanical calculators, like Schickard, was an all-around genius. I bet you've heard of Pascal. Yeah, Pascal's triangle. He did things in mathematics. He did things in statistics. He did things in probability. He did things with dynamics. He did things with thermodynamics, even before that was a field. He did all kinds of things. Pascal wanted to be known as a natural philosopher. Today, we would call that a theologian. While many people were religious in the 17th century, Pascal was a committed Christian, which is a little unusual. And in one of his major works, he says this seems strange. I defined my life backwards so I can live it forwards. What did he mean? What he meant was this. Okay, not exactly. But what we think as the last thing, outputs, is really the first thing. What Pascal meant was, as a committed Christian, he said, look, I want to know what happens at the end of my life. At the end of my life, is there anything beyond this life? Pascal said, yes, there is. Two things, heaven and hell. Pascal says, how do I get to heaven? Let me read God's word. God said, you can't do anything, Blaise. I've done it all. When I impart faith in your heart, you're set. So Pascal said, that's the answer. When life is over, I do want to be in heaven with Christ. So I've defined my life backwards. So now in the present, I can live it forward towards that goal. And for Pascal, that embodied the concept of vocation, good works, not to earn salvation, but to be God's mass in the world, to assist other people. Moral of the story for us software engineers, think backwards. Outputs are first. Where are you going? What is your goal and destiny? On the basis of your answer, then, you plan the route accordingly. I mean, this applies to any kind of travel, right? How would you drive from Irvine, California to Mequon, Wisconsin? Well, first you got to know where you're going, Mequon. And then I just put it into my online, yeah. The very beginning of this course, I shared with you 3 aspects of the creative process. All creative acts are Trinitarian in nature. Software engineering is a creative activity. We create software tools that other people will use to solve problems. Any and every act of creation is threefold. Now, this isn't necessarily arranged in an order, although we'll think about it that way. One aspect of creation is idea. What's that? You know what an idea is. An idea is the mental model. It's the construction in our mind of what I ultimately want created. It's, for computer scientists, it's the formal and mathematical properties of the algorithms we're ultimately going to produce. But that's something we run around in our mind, first of all. Don't make the mistake of getting an assignment and immediately running to the computer and throwing code at it. You've bypassed this very important step. Develop the idea. Just because you can't see it percolating in your mind or my mind doesn't mean it's not an extremely important activity. This, by the way, is Unit 1 of CSC 222. I entitled it The Idea of Software Engineering. What's that? For us, requirements and specifications. Requirements and specifications, that's the idea, the mental models behind software engineering. The second aspect of creation is implementation. Implementation says, take the mental construct out of your mind and put it into some concrete form. For us as software engineers, that means designing and then creating the code. Implementation. Computer science terms, we're talking about the hardware and linguistic realizations. Linguistics is just language. And you know the language of computer science is software. So for us, because we're not building the hardware, we're going to build the software. That's implementation. This is Unit 2 of CSC 222. Implementation is all about design and instantiation. Third aspect of creation, interaction. Sometimes people think, well, if you made the real thing, it's all done. No, it's not all done. It's not done until somebody uses it. A creation is not a creation if it's not used by somebody else. If you make something, put it in a box, wrap it up, yeah, no. Something that is created must be used. This is the interaction. Now, and that's the final two steps, right? The deployment, get it to the user so they can actually execute it to solve a problem. And then what about maintenance when the user discovers it didn't really do it? Interaction. Somebody has to work with it. Then it's complete.
That's what I'm trying to.
Yeah, question. Did I lose you, Ridge? Question or somebody? No? Okay. They pop up. Don't worry about interrupting. You'll be just fine. I've used the term sprint a couple times, and I've mumbled about Scrum. We're going to investigate Scrum as a variation of a software development lifecycle in the next unit. Scrum is, there was a little bit that you read about it in a couple of the chapters. Scrum is a philosophy more than it is a software development lifecycle. It's a way of thinking about doing the software development lifecycle. One of the key characteristics of Scrum is we don't implement the entire product at once. Instead, we take it in viable chunks. So you come up with the idea, but then you break it down into what Scrum calls sprints. A sprint is a potentially shippable product at each stage, but without all the functionality. So what we did in sprint 1 is not the final thing. Same with 2, and now in 3, there's more. Same core content, but we've added some features and functions on top of it. Do you have any questions or comments about, do I have Blackboard here? I may not. I got, oopsie, what happened? Well, yeah, I know how to do it. There. Do you have any questions or comments about homework assignment 11, which is our next sprint into add numbers? Let's see how long it takes me to get Blackboard up so I can actually pour there with you and see. Not as long as I thought. Oops. Oh, hang on. That's why. So, homework assignment 11. 4 was sprint 1. 7 was sprint 2. 11 is sprint 3. Be sure that you begin with satisfying all the requirements and specifications of sprint 2. We'll look back. Now add the following. I had a question afterwards about this trap for invalid input. What do I mean? In the previous sprints, you trapped for erroneous input. An A is not a number. So you trap that and say bad. And don't forget, now don't put a pop-up. You actually have a text box on your form where you'll output error and what was going on. Invalid input. What we are inputting are weights of objects, shims. Now, a weight by definition can be a positive value. Therefore, if the user typed in 0, which is a legitimate number, you would flag that, you would trap that, you would not add it. You would say, hey, invalid input. If the user entered a negative value, you do the same thing. Ultimately, we'll see that these shims need to be in a range. They're actually fractions of a pound. So if the user typed in 13 tons, that would also be invalid. But for now, no negative, no 0 inputs are allowed. On the second one, implement a save and print feature. Now remember the difference between a feature and a function. The feature is the outward facing thing. So the user is going to see a menu item. Did I spec that? I guess I just thought it. I would like to see it on the menu. Remember you had the help menu, you made a menu with help before and you're going to populate it now? I'd like to see that on the menu. So 2 things on the menu, help, and now save and print. It will not say you don't have to implement that function yet. Save will be implemented in the next sprint. But what you will implement, the internal function, will be print. What print will do is several things. First of all, it'll display a pop-up window. You know how to do that. And that will include the total weight and the count of shims. Please format that. Instead of just an output box that has 2 values, you'd say total weight of shims, blah. Total number of shims, blah. After that happens, After that pop-up window appears, you will reset. You will clear/reset. In other words, you will set your both running totals back to 0, and you'll clear out anything on the form that might indicate, hey, it's so many pounds or what have you. This thing here, you do that on the form. We've seen that when you select a text box, you can bring up the properties. Did I say form? Strike that from the record, Your Honor. You do this on the properties of the text box or whatever feature you're using for output. I think we're all using text box. Set that such that it's an output field. It will not allow input. That's a property for that text box. Pour through there or search and figure it out. Next, implement the help menu. So now, before it just was a menu. If I clicked it, it didn't do anything. Now, some of you already did this. Good. So now you'll have some help. Give some rudimentary help for the user. You decide what that might be, but think about the user and how the user's approaching the problem. Any questions on assignment 11? While you're thinking about questions, I mentioned last time that I had contacted your IT support department about getting a license for Windows. And they said, yeah, we can do that. And then they came back and said, well, it's taking a little longer. I'm sorry, I haven't heard anything back. This is sort of like the person painting my car. Well, you know, things do legitimately happen. And Irvine IT support isn't just dealing with me. I know there's a lot of things going on. So I think an unlicensed version of Windows is not legit, of course, and is not what we want, but it'll work for you for now. I'm hoping that we can get licenses for those of you using a Mac, running a virtual machine on top of that Mac, running Windows in that virtual machine, can actually have a legitimately licensed legitimately licensed product, Windows. Got to learn how to spell. All righty. I asked you to read this article online. What you see here is the revised and updated 21st century book of the Mythical Man Month. The article you wrote was at the end of the 20th century, so it's very old, I know. But the concepts and ideas are still very legitimate. When you read through the article, can I just highlight a couple things? Fred Brooks said, programming is a tar pit. That's, you know, you guys, Southern California, hopefully you've gone by the La Brea tar pits as I did a million times in California. It's a tar pit. What's the idea? You're attracted to it, but then you get mired down into it, right? I mean, programming, yeah, I want to do that. And then I get stuck in all this other stuff. Here's something that we've said in class that Fred Brooks also says: a product isn't just a program. Don't forget, the official definition of software is code plus documentation. Brooks lists some reasons why programming is fun. You can read those and agree with them or not, but one of the things he says, which I absolutely agree with, is it's a creative endeavor. This is a creative process. I could never get my university to consider programming a creative art for a core, but it really is. It's a fun, creative activity. We get to make something, and we make it out of pure thought stuff. That's cool. He has some reasons for why programming isn't fun, and you can agree with some of those too, like, whoa, semantic errors. I could do without those. And then he gets to the mythical man month. And I asked you in assignment 9 to, oops, do I want to talk about this? Oh, yeah, I do. Sorry. I asked you in assignment 9 to share with me in your own words, what is Brooks' law? Brooks' law is related to this concept of the mythical man month. I'll show you the Dilbert cartoon again in a minute, just in case you missed it before. In order to understand the last thing I want to talk about in this unit, estimation, Brooks gives us some insight on why does software fail. First week, we talked about the software crisis and the unholy trinity. Software, what do you mean by fail? Software might be behind schedule, might be late. Software might be over budget, costs too much. Software might be full of bugs. Those are all indicators of software failure. Brooks says it's difficult to estimate the time it's going to take. I know I experienced this when I was a student. I'm sure you have too. Okay, this will probably take X, so I'll begin on Y date, and then suddenly it's, whoa, totally underestimated that one. The other thing, and this is just endemic to, I don't know why, but to computer scientists in general, especially working software engineers, optimism. They'll say, okay, I didn't make schedule today, but tomorrow is a better day, and I'll make up time tomorrow. This is where Brooks gets deep, but it's very important to understand. Brooks says effort does not equal progress. Effort does not equal progress. You can tell me, hey, I spent a lot of mental time on assignment 7. I spent a lot of time on it, and I believe you. But then you say, but I don't have anything to show for it. Right. Effort does not equal progress. This was true of software development in the second half of the 20th century. It's still true of software development in the first half of the 21st century. We don't monitor the schedule. If you come up with a schedule, people don't stick to it or monitor it. That's the purpose of these milestones. Have you created the requirements prototype? Somebody needs to check on that. When the schedule slips, that induces the addition of people. Management says you're behind schedule, add programmers. You do this one. You do this one. That's assignment 9, Brooks' Law. Can I give you 2 examples of Brooks' Law? Mr. Johnson detects a slight problem in Joe's otherwise flawless business plan. Says here that you've hired 9 women, so busy professionals can have a baby in just a month. Yes, sir. Oh, that's right. I deleted the Dilbert one because we already saw it. Oh. Don't forget that software is defined as code plus documentation. By documentation, we don't just mean comments in the code. We mean requirements and specifications and prototypes and other things. Comments in code are good if they're good comments. And a good comment explains why. If you have a comment by an assignment statement that says, remember this, no, I know what that does. Tell me why you're doing it. In honor of Willie Mays. Zeb, I wondered why the baseball was getting bigger and bigger and bigger. Zeke, yeah? Zeb. And then it hit me. And then it hit me. All right. You're just going to have to read about diagrams because I got to talk about estimation. I was going to do a little bit more. Oh. I got to do this. You know about CAPTCHAs, of course. Do you know that at my university, behind our firewall, behind my.cuw.edu, there are some places where you go and then you have to answer a CAPTCHA? Give me a break. You've already authenticated. What do you think? But here's the weird thing. Have you thought about this? Apparently, robots can't pick out traffic lights in a street scene. If robots can't pick out traffic lights, should they be driving Teslas? Oh, now you're going to yell at me about that. Thank you. Estimation is the last major topic in this unit. A little bit in the text. Let me preview that for you. One of the documents created in the specifications phase is a planning document. And in that document, you're going to list how long it's going to take you to do this project. How in the world can we do that? Well, what it came up all together? One at a time, please. Sorry. Okay, ignore the next two. There are two basic ways to do estimation. The first is called heuristics. Computer scientists, you recognize a heuristic as a guideline, as a rule of thumb. It's not an algorithm, but it's sort of something that feels in your gut like it's going to work. A heuristic, rule of thumb, guideline. What are the heuristic models? Well, the heuristic models are just that. In companies, there will be people with lots of experience, people who have worked in the company for a long time, gone through the development process numerous times, and they have an internal clock. And they can say, this new project seems to me like it's going to take 19 months, 3,000 people hours. You say, how'd you do that? Well, it's sort of like a professional baseball player. If you ask a professional baseball player, how they hit a curveball, they couldn't tell you. It's just those 10,000 hours of practice, and it's just all automated. You get in a slump when you start thinking about, how do I hit a curveball? Yeah. It's that internal gut level reaction. Now, doesn't seem very scientific. And this can be wildly wrong too. So another way of estimating are the algorithmic models. An algorithm is just that, a detailed, unambiguous set of step-by-step procedures for solving the problem. There's a mathematical formula. Get the data, plug it in, go. The most widely used arithmetic model for estimation is called COCOMO. This is not the Beach Boys song. It's not, and that's spelled with a K anyway. It's not the city in Indiana. COMO is a contraction for constructive cost model. You'll read a little bit about it in the text. I will not ask you to actually use COCOMO, plug in numbers, and figure out what happens here. We'll look at that, I think, maybe at the beginning of the next unit. But I want you to have a sense for, okay, if I need to estimate how long this software development process is going to take, How do I do that? On the one hand, if you have lots of experience in software engineering and developing previous products, a heuristic model might work. Your internal gut reaction, the guidelines that you have formulated and developed, you've seen it before. I've been there, I've done that. This is what I think. An alternative is to use a mathematical formula. The formula, you know that every algorithm will produce some output. The output produced is a time estimate. But the interesting thing is, what's the input? Yeah, okay. I'll let you read that. Now, I'm going to pause for questions. And then I don't want anybody to be surprised on the upcoming exam. Of course, if I tell you directly the questions, that means I can expect much more of you, correct? Of course. What are the odds that I would ask you, what is software engineering? The title of this class, software engineering. What are the odds? 100%. Don't just write the management of the entire software development process. Consider what, why, and how in your answer. There's more to the what than just that single statement. Why is it done? How is it done? That's a complete answer to the question. Now, in the software development lifecycle, the framework for how we're going to do software engineering, we focused on two different phases: requirements and specifications. What do you think the odds are that I ask you about those two phases? 100%. So it's very legit for me. Yeah, nice try. Nice try. What are the odds that I'd ask a question like, what is the purpose of the requirements phase? What is produced and why? What's its purpose? What's produced? Why? Yeah. Really high, like 100%. And the exact same question, just substitute specifications. What's the purpose of the specifications phase? What is produced and why? Oh, yeah. Yeah, I'm going to ask you those things. The exam has just 3 short answer questions. And please, they are short answer. Don't write in full paragraphs with a thesis and a topic statement and say, no. You don't have to repeat the question. What's the purpose of the requirements? So just begin answering it. That's good enough. In addition to some short answer questions, there'll be some true-false questions and some multiple choice questions. To study for the exam, review your notes, the notes that you've taken either during class discussion or as you've been reading. You can take a look at my notes that I posted online as a hook into the readings. If you never read the chapters once, I think that was a good idea to do. But if you have to allocate your time, then review the notes and review the notes that I have posted online too. If you ever need to really check something like, gee, what were those 3 questions he said again? Well, I mentioned them on last time, I mentioned them this time, and I do post these course casts. You can go there. You know, the videos are there. Oh boy. Oh boy. All right. Questions, comments, concerns that you have? Final thing then before you go, at Concordia University, Irvine, at the end of the 5th week and the end of the 10th week, faculty are supposed to somehow report how folks are doing in the class. And I believe at Mequon, we report everybody's grade, but I think that just folks below a certain level. And I don't know, I got to double check. Do I put this into a system and then you're alerted, or do I contact you directly? I will be doing that. That's the task for this weekend. That's still the end of week 5. All right. The vast majority of you doing well. Thank you for your hard work. Keep it up. We're done. Have a nice day. Have a happy rest of your week and weekend. I'll see you on Monday.